Application Programming Interfaces, or APIs, are not just communication layers. In modern systems, they are long-lived products that must evolve safely over time. This is why the API lifecycle is treated as a disciplined engineering process rather than a simple development task. Welcome to Topictrick, where complex concepts are broken down into simple, easy-to-understand lessons. In this video, we examine the API lifecycle through its critical phases: design, development, testing, deployment, versioning, and deprecation, using real-world engineering practices followed by mature software organizations. The lifecycle begins with API design. At this stage, teams define the contract between producers and consumers before any code is written. Design decisions include resource modeling, request and response schemas, error handling standards, and authentication mechanisms. For example, a well-designed commerce API models resources such as customers, orders, and payments using consistent naming conventions and predictable response structures. Many teams use OpenAPI specifications to formalize the contract and enable early validation across front-end, back-end, and partner teams. Once the contract is agreed upon, the API moves into development. Engineers implement the defined behavior using frameworks suited to their scale and performance requirements. This often includes stateless services, dependency injection, and structured logging. For instance, when implementing an order creation endpoint, the service may orchestrate inventory checks, pricing calculations, and fraud validation through internal services, while maintaining idempotency to prevent duplicate transactions. Testing is a critical phase that extends beyond basic functional checks. Unit tests validate individual components, while integration tests verify interactions with databases and downstream services. Contract testing ensures that the API implementation remains compliant with its published specification. Load and stress testing simulate real traffic patterns, such as peak usage during flash sales, to identify performance bottlenecks before production release. After validation, the API is deployed to production environments using automated pipelines. Modern deployment strategies often include containerization, infrastructure as code, and continuous delivery. For example, a financial services API may use blue-green or Canary deployments to release changes incrementally while monitoring latency, error rates, and system health metrics in real time. As business requirements evolve, versioning becomes unavoidable. Backward compatibility is a primary concern at this stage. Teams carefully assess whether a change can be introduced non-disruptively or requires a new version. A breaking change, such as altering response structures or validation rules, typically results in a new major version. This allows existing consumers to continue operating without immediate modification, while new clients adopt the updated behavior. Eventually, older versions enter the deprecation phase. Deprecation is not an abrupt shutdown, but a managed transition. Engineering teams publish deprecation notices, update documentation, and provide migration paths. For example, a logistics platform may announce that a legacy tracking endpoint will be retired after 12 months, during which usage metrics are monitored and clients are actively supported through the upgrade process. A practical example can be seen in large-scale ride-sharing platforms. Early API versions may support basic ride requests, while later versions introduce dynamic pricing, real-time driver matching, and enhanced security controls. Each improvement is carefully versioned, deployed, and eventually consolidated as older versions are deprecated. In summary, the API lifecycle is a continuous engineering discipline that prioritizes stability, scalability, and consumer trust. For advanced practitioners, mastering this lifecycle is essential to building APIs that can evolve safely while supporting complex distributed systems over many years. Don't forget to subscribe to our YouTube channel for more such videos. Thanks for watching the video.